Hello everybody, today we're going to talk about remote graphic. Let's dive in. Agenda for today, remote graphic, why and for who, remote desktop or remote workstation, which one, architecture options, security and network, and we'll have time for demo at the end. Remote graphic, why? Since we've been forced to work from home, there's been many instances where this solution was very useful for many users, especially about flexible hours where we could be working from home or other locations at a specific time that we want, so we don't have to be in a physical office. Saving time and money, for example, not having to travel to commute to the office, avoiding traffic, and of course, protecting employees' health since the arrival of COVID-19. Remote graphic for who? Let's start with creators first. Applications like 2D and 3D are hard to transport. If you're looking at complex 3D animation, 2D editing, and others like that, it's not easy to bring those applications where you are working if you're working in a different location than your main office. Of course, data security is really important, so we need to keep the data is secure at all time. And everybody worked in creating environment. Really enjoy collaboration with peers, with managers, with creative directors. So that's also very important. So these would be the type of people who would need remote graphic solutions. From remote desktop to remote graphics. So let's look at where this is all started. Back in 1993 around, Microsoft have put together a solution that basically was a remote desktop allowing a remote PC to connect to another computer in a different location, either on premises or elsewhere. The concept of sender receiver have not really changed, although the performance, the security level, the ease of use have tremendously been improved. The concept of going from sender to receiver is pretty much the same today, and we're going to see that to our presentation today. There are a plethora of remote desktop software. We're not going to dive into those. We're basically going to look at a different category, but just so you are aware, there is more than 50 plus type of solution that are software based, some are hardware based, but basically they do not comply with a remote graphic solution because they're basically designed for standard basic office work like sharing your Word document or Excel spreadsheet or even very basic web browser application. They're not designed for heavy graphic type of environment. We have Windows support, Linux, Mac OS, even to an extent Android and iOS. These are desktop application, not graphic. Before we talk about graphic applications, let's talk about what is the server type or the workstation type that we're going to use in this example. Example, basically a workstation. The difference between a workstation and a desktop is an instance of a computer that have a dedicated graphic component, which is not embedded in the CPU itself. So it's a complete separate type of controller, mainly designed by NVIDIA and AMD. And these are classic type of graphic card you're going to use to make your software run. Now let's talk about the remote graphic software protocol. So this is the piece of software that we're going to install on the sender to allow a user to get a very, very rich graphic experience. Three main manufacturer, Teradici with their PC over IP solution, HP Z Central Remote, Boost that used to be called RGS, and TGX by the company Macdyne. Remote graphics software protocol, these are the benefits. First and foremost, really important, the image quality. Not only the resolution, but the frame rate, the refresh rate, the fact that I would connect remotely to another computer and the image quality will be at its best. Of course, there'll be network consideration we're going to talk about later, but basically that's the number one thing. We cannot do image quality or any type of quality without making absolutely sure that the data is secure. So the data is staying at the sender level, never sent to the user, only the pixel and the audio. The one of the important part about remote graphic software is they're completely independent from the application. There are many desktop type of software that you can install on a PC that would potentially intervene with the application, and the application behavior will be impacted. Either you'll have graphic visual that will impact, or you'll have performance issues. So again, a graphic software protocol will not impact the application whatsoever. And we're talking about multi-display, we're talking about 4K support. All of these complies with a remote graphic software environment. Now, to design a remote graphic environment, we need to take what we call the 7 links. Basically, there are 7 really core components that each of them have their own specifics. And when we design a remote graphic solution, we have to consider all of these 7 very carefully. So from the type of application, that's the number one thing. What application are we going to use? Is it a CAD application? Is it a 3D software? Is it a 2D editorial post-production type? Is it a highly graphic real-time game engine of the like? So that's the number one. The number two is the compute. How many cores and RAM and storage I need for that application to run. The storage, I will eventually going to grow the data for this application. So where is this storage will be located? The network, how fast it is, how far am I from the sender to the receiver. These are all very important, and we're going to go to a detailed network analysis later. The protocol itself, again, sender receiver, which protocol we're going to use, they all have their specific. The security, we have to consider security all through. And one of the things that is somewhat forgotten in many remote graphic deployment is the end user endpoints. What is the user is going to do? How many display? What the resolution of those display? Would that person would need a digitizer tablet to paint and draw? And of course, if we're working from home, what type of home network that the user will use? These are the 7 links that makes or could break a remote graphic solution, and they have to be considered separately. So there's 3 main architecture when we design a remote graphic environment. So this is really important because we're going to go and come back to this often, which is first and foremost a remote workstation classic. The use case has been done for 15 years. So we're going to talk about that separately, but it is basically installing a piece of software or eventually maybe a piece of hardware to make that computer available remotely. So that's what we call remote workstation. Then in the middle, the tier 2, we have virtualized workstation. So similar to the one on the left, but with the fact that you can take a computer, install one graphic card or multiple graphic card, and you can split those as we do with servers and make a multiple user per server. So we call that virtualized workstation. Third and foremost, it is possible today to have highly intensive application running in a public cloud hosted by the main 3 public cloud vendor, which is Microsoft, Amazon, and Google. And we'll have an example in our demo about that. So let's focus on the first one. Let's talk about the tier 1 remote workstation first. So remote graphic in a remote workstation, very similar to what we've been seeing already, which is a sender piece of software or eventually a piece of hardware that will encode the image and the audio and will send that to a receiver in a sender receiver function. But in this case, we have not only a GPU card that performs all the graphic for the application, but also redirect all the APIs, which is OpenGL, DirectX, and others. I'll use these 2 because they're the most popular in Linux and Windows environments. So basically, the receiver will have a very similar experience that if that person will be locally connected or logged in to that computer, but remotely via the network. There are other elements of remote graphic. For example, there is a concept of what we call one-to-many, where we see that in simulations where the user will have the 3D data sets, but will do testing and simulations and will use two workstation. We can do that with remote graphic, so that person could be located remotely and have access to two complete separate workstation. We call that one-to-many. Another aspect is many to one. It's a bit of the reversed. Basically, there will be one sender, multiple receiver, a little bit like you will do, with a shared desktop when you present in a Skype, Teams, Zoom, similar concept where the user will receive the pixel shared by the main sender, but the experience will be much, much, much better with better quality of graphics. And the remote user could eventually take control of the mouse and keyboard to be able to share with the other team member and interact with them. Um, I will not go in too deep detail about the Mac OS environment. Just understand that it is possible to do a sender receiver highly with high quality with a Mac OS environment, but there is some limitation either from a performance standpoint or the cost could be a little bit more than we see on Windows and Linux. If you have more needs for those kind of environment, let us know offline and we'll come and help you with that. So let's look at the Teradici PC over IP concept. So basically this is a protocol that allows the user to get a very rich graphic experience. And there's been, from a historical standpoint, two main architecture that Teradici have been developed. The first one was hardware. So the initial PC over IP technology was using a host card that you see on the left here that have a specific chip on it that would encrypt and compress the image and send that to the user at the other end using the decoding chip on a zero client, and will have a perfect experience, and also will completely remove any burden on the CPU to encode that image, so it would basically give one of the best experience out there. Eventually, Teradici was able to convert that technology into software. So we have today a software version of the same capacity with some additional benefit. So you can put a piece of software on the sender as well a piece of software on the receiver and then get the same experience. Take note that you can go one way to another. So you can have an hardware host card and a software receiver, or you can have a software sender and a hardware receiver. So both can be interchanged, but just note that there is a new version that's been launched a few months ago by Teradici. It's called PC over IP Ultra that allow for 4K support, 4K resolution, and that's only available on the software. So if we look at where this is all coming from, so if, at the beginning, Teradici, as I said, launched their technology on a PC over IP host card that was installed in a workstation, then eventually migrated that to a data center. So it is possible to put those cards in a server-like environment or a racked mount type of computer, and then migrated to a full cloud private concept where it could be shared amongst multiple resources in multiple centers and fully migrated into public cloud. So there is many offering today from Teradici on the public cloud for user performance. Quickly, we'll look at what HP is offering. Again, very similar concept. It's a software-only solution from sender receiver. It is included in all the HP Z workstation class. It used to be called RGS, now rebranded to HP Z Central Remote Boost. And again, very similar concept. Again, HP does offer support for 4K, multi-display support, and graphic hardware acceleration, and another element that HP offers. It's called HP velocity. Basically, when you are connecting far from your sender, when a receiver connects far from the sender, there might be some packet loss throughout this transition. Then HP have developed a special feature called HP velocity that will basically resend the packets as soon as the receiver thinks there's a problem to avoid bandwidth consumption and keep the quality at its best quality possible. One of the main goal from HP for that solution is to use a one-to-one remote graphic from a workstation to a user in a rack type fashion. So basically, HP offered today, for example, is a 2 Mini that is an entry-level class workstation with NVIDIA GPU support, and you can stack them in a rack and get a very, very good density. Another piece of software for remote graphic, another offering from a company called Magdyne. They offer a tool called TGX, has been used with many customers already, offer similar performance, similar costs, and it offer a floating sender license, so you could install many instances of the sender and having a first come first serve, if you will, concept. Can have up to 4 collaborators connecting at the same time on the same sender. And TGX offer a virtual cloud workstation support and many receiver from Mac OS, Linux, Windows. By the way, all three of them offer multiple receiver, and the receiver software is always free of charge. So if you want to collaborate with a collaborator that's outside of your organization and you don't want to have them to pay for the receiver end, all these manufacturers offer the receiver at no charge. Now let's quickly look at the virtualized workstation. So again, this is like a server virtual, but it have GPU and it have end user OS support. So a virtualized workstation allow multiple user connecting to a graphic server installed in a rack function, and there are many software and hypervisor that we call that offer that capability from VMware, Citrix, Red Hat KVM, and Nutanix. And basically, they will allow multiple user to connect to a server that have enough CPU, RAM, GPU for those users to connect. And in the middle, we will install what we call a broker manager that will tell who's connected to what instance, what that person resources should be. For example, we can have entry level people that do basic CAD design. We can have middle type user that do a little bit more intensive work, and we have there's always a group of people that will need more capacity, more power, more graphic GPU. So this can be all set up in software pretty much, and then assigned to the right people, and that could be changed over time. So again, another way to look at it, we could use a virtual concept to do what we call pass-through. So it's basically we shared resources, we shared CPU, memory, network bandwidth, storage, but each user have their own physical dedicated graphic card. So everything else is shared, but the graphic card is fully dedicated as if it would be locally installed, like if we would install those graphic cards locally to the users. That allow for full performance from a graphic standpoint, which is sometimes required in some installations. So to give you an example how this works, so let's look at one component of that solution, which is a NVIDIA Tesla M10 graphic card from the solution from NVIDIA. So this card have, for example, 32 gig of totally memory, graphic memory, but divided in 4 different isolated CPU chip that each have their own memory capacity of 8 gig per graphic component. So basically, if we look from a concept of a single card that have a single GPU, you would eventually be able to divide that by users, but you will share resources from that card. What the M10 have, it have four discrete GPU module in that single PCI card. So you can basically isolate it completely, every users from, the performance, from the memory buffer, from the CUDA cores, all of those things are fully isolated one another and give the user full capacity, full performance. And then you could put four users on that same cards, and you could put more than one of those cards in a single server. Some can support two, some can support four of those cards. So then you can have a much higher density per server and then for saving cost. So let's look at what are the gotchas if you are planning to do a virtual environment. Basically, there is no way today to virtualize a Mac OS environment. The ISV support, the independent software vendors, may not necessarily allow from a license agreement to virtualize an environment like this. So this is really important to look at that early on. Will my application be allowed to be virtualized? Not every application allows that today. I would say more than 60% of professional software allow that, but not every one of them. The GPU scaling, so how many user we can put in per graphic card. That's a big topic when we design virtual workstation because, of course, the more user you can put, the more money you're going to save. But of course, there's a price tag attached to the performance also per user. So the user experience and the user performance is really important when we design those. Virtual workstation required that someone will have to pay to install this whole server and switches and additional license server and connection broker. So initially there will be a capex investment done by an end user or a third party who will install that on your behalf, and then you can rent those by the month. And it's a somewhat complex solution to build, so it's not something you can build over the weekend. So third remote graphic architecture is public cloud. So I just want to restate here that I really want to focus on public cloud as we define that. Basically, Microsoft, Google, and Amazon offer GPU-enabled virtual machine with good performance, and on top of that, adding a performant protocol. Most of them today offer Teradici as their preferred remote graphic protocol. So this is what we're going to talk about. So before we go dive into the cloud environment, there are many easy way to deploy a remote desktop. So it's basically a Windows 10 or a Linux desktop OS that you can launch and use at your leisure. And these are very affordable, and this has been available for many, many, many years, and it's working fine. I don't have an example of Google, but all three of them offer that. So it's a simple, remote desktop concept. But this is not what we want to cover in this webinar. So remote graphic in the cloud is available from Microsoft, Google, and Amazon, but it's a bit complex to design because there's many, many module to add to make it a full scale, full performance remote graphic instances. So there are many companies today that do that for you. So you basically can use some of these companies will offer a full turnkey solution, and all of them have some special recipe. All of them will offer their easy onboarding deployment. They all have pro and cons. They all have their specific. But basically, just remember that instead of you going and try to build that by yourself, you can use one of those companies. Remote graphic in the cloud, the gotchas. Too many times I'm talking to people who say, well, I can run a virtual GPU machine from XYZ public cloud and I can just launch it. Yes, no problem. Anywhere in the world you can do that. But what is going to be a performance if you are far from the data center? And now comes the concept of latency, meaning the delay between you and that instance. So again, sender to receiver, how far are you? The GPU availability, there is many data center, but not all of them have currently GPU deployment. So it's really important that you say, well, I think there is a Microsoft Azure data center near where I work or where I live. Great. Well, is there GPU installed? If yes, which type? Would that be sufficient for your needs? So again, it depends on the geography that you are located. The price is based on a per hour basis, and as you can see here, is not cheap. So if you are looking at a solution in the cloud to be very performant, you certainly have to rethink about your costing model. And would you need that for a full term, 40 hours a week, constant usage? Well, you need to be ready to pay a premium for those kind of things. Um, Most than often, the GPU virtual machine in the cloud are somewhat overspec'd from what you are using if you're using a classic workstation tower, for example. There are many areas where there'll be too many cores than what you would normally need. Your application will not even benefit 30%, 20% of that. In some instances, there are massive amount of RAM. The majority of the workstation user will use between 32 and 64 gigs of RAM. Many cloud instances will offer 128. Not sure why, but this is the reality. And again, if you want to build it yourself, completely from scratch, it's a bit complex. It's a bit more complex than you might think. So we've covered remote workstation, virtualized workstation, and public cloud for remote graphic architecture. But there's two other elements that we really need to look at, which is security and network. So let's talk about those. So what I brought here is a zero client. So again, it's very similar to what we saw earlier, but there's a zero client here instead of a laptop or your home desktop. There is a very good reason to use a zero client, and the main reason is security. Because what is zero client is? Well, let me show you. A zero client is basically a small device that have the PC over IP software chip. The software is embedded in the chip. So there is a decoder chip that you will have at your on your desk that will basically going to talk to the sender that have the Teradici sender software or hardware. So that allow for maximum performance at a very low cost at your receiving end. It's fully password protected. And I really want to emphasize that there's no OS. We call that a zero client because there's zero OS. It's basically a firmware, which is a piece of software that's embedded in the hardware device that basically log in and say, where's my Teradici sender? That's all it does. There is no web browser and there's absolutely no local data saved locally. So if you would use this at home, and somebody would come to your house and steal that device, well, there'll be absolutely nothing on that device. So fully secure. For example, I'm going to take one of those brand by the company Tenzig, and they offer a range of zero client that have single display, dual display, 4 display, 2K, 4K, and there's plenty of USB support, and those USB ports are there for mainly for mouse and keyboard, and eventually a Wacom tablet. And as you can see in the middle here, when you are connecting, there's a light that go green that says, hey, I'm connected to a Teradici PC over IP sender and you are good to go. So another visual clue for the user to say, yep, you are connected. Another reason to use a zero client is to get maximum Wacom tablet support. So in a tablet deployment, as of today, only the company Wacom offer full support in a remote graphic environment. And the best quality of interaction between the Wacom tablet and the sender machine is used by a what we call locally terminated. So basically, the Wacom tablet behave as if it would be local, and the user have the perfect experience. So again, that's another feature to consider in a remote graphic deployment. I took a screen capture with my camera of my display when I was using Azure Client to show you what the user sees. This will be all set up prior by the administrator, and the user will basically connect either a local server or a remote server with a specific host name, and we'll put credential, username and password, and that's it. That's all the user will be able to see. The user will have the capacity to modify the display settings in terms of how many display and what the resolution are. The audio is the audio through a USB headset or through a regular audio plug cable, and mouse, keyboard, and tablet connection. That's all. That's all there is for the end user, but it's very different from the administrator standpoint. The administrator will be able to fully configured, update, um, disconnect the 10 client or the zero client remotely through a web browser portal administration. So we'll be able to define the connection type, the certificate for security standpoint, host name, and there is a very long list of feature that the administrator can do using a zero client. So that was the security part. Now let's look at the network component. Everybody's saying, okay, what type of performance I need for my remote graphic instances? How far can I go? And things people don't think about is, well, would there be traffic on my network? Maybe, maybe not. So these might sound basic for some of you that are a bit more technical, but I think it's important we go back to the basic about the network deployment in a remote graphic environment. So the bandwidth, which is the size of the pipe. And many people confuse that with, well, I need the maximum bandwidth and I need to talk to my ISP provider because I cannot do remote graphic from my house. Well, that's not necessarily the case. It depends what type of environment you have. I would think that dial-up and ADSL may not be great. 10 megabit per second could work. But you don't need to go to 1 gigabit for sure, and even to 100 megabit per second. Between 10 and 100, totally fine, which is somewhat covered in large metropolitan area and even to an extent further suburbs. So, but it all depends what type of environment. And again, back to the roots, what application are you using? If you're using some 3D application that have a small window that you interact with, you may not need more than 2 or 3 megabit per second. If you're doing tree display, some of them might be 4K and you do full playback, video editing or stuff like that. Well, you might need a bit more. Again, it depends on the application you're using. The latency is the distance between the sender and the receiver, and how fast the data will move back and forth. Mainly because when you're going to move your mouse and keyboard and you're going to interact with the remote instance, how long is going to take for that transition to go back and forth, and that's what we call latency. It's very easy to measure, and it's very easy to predict the experience you're going to have. And I just put 15 millisecond here. Millisecond delay back and forth for a total 30 millisecond round trip. But it's just an example. You can go up to 80 millisecond, maybe to 100 millisecond. Under 20 millisecond, you're gonna get perfect Wacom tablet experience. Again, it all depends, but that's really important to measure before we deploy it. Something that we don't talk often, but that's really important, is the number of hops. So basically, the number of time the data will exchange hands. Either it's a switch, it's a hub, it's going to your house, it's getting out of the office, whatever. This is really important to measure because it will impact greatly your experience, even if you have the biggest pipe ever, even if you have very, very low latency. From the full end-to-end solution, we need to know what those ops are going to be. The thing that is also not considered enough in my experience with customers, traffic change, right? Like regular traffic, you're gonna have more busy traffic in the morning and the evening for car traffic. Same thing with network. There's a time during the day that there'll be more traffic, and that's very, very hard to predict. So when we do testing with users, we need to consider when those tests are done and at what time during the day, and is it recurring? Will the traffic jam will happen always at the same time during the day? Then the user will know, well, between 4 p.m. and 5 p.m. there's more traffic than the rest of the day. So that's really important to measure, and there's many ways to measure that. So three things I want you to remember from that point of networking, which is the distance. Is the network is going to be slow, unstable? Of course, please do me a favor, do not use Wi-Fi in your house if you want to have a great remote graphic experience, because Wi-Fi have never been designed for that type of solution. So let's recap all of these three solutions that we've looked at, and let's look at very high level rough price number. So back to our basic remote graphic solution. Well, if you want to buy a workstation and install a remote graphic software or hardware, these are usually amortized over 3 years, and you will get between $75 to $150 per month over 3 years to amortize that investment. And this is designed for people who have workstation, who want to buy a workstation. So this is a perfect solution. Remember that there is a tower, but there's also an offering today that look like a server, but it's a full remote workstation feature that you can put in a rack. But it is a classic Windows or Linux remote desktop concept. The tier two, the virtualized workstation, if you want to build and deploy that yourself, or if you want a third party to do that on your behalf, you will pay between $250 to $400 per month per user for the exact same performance. So going from tier one remote workstation, when we virtualize for the same performance, same capacity, same remote protocol, you're going to pay that kind of price. And this is designed for people who want to deploy that for the long term, for new studios that want to build a brand new facility, and also people who are looking at a capex investment. The third one, the public cloud, the price range between $3 to $7 an hour, so that can add up between $500 to $1,000 per month per user, depending on the capacity that you need. This is designed for smaller group, for short term, so you need it for a few months, for a few weeks, and it's really more like in OpEx spending, where you say, okay, I'm going to spend. I know exactly how it's going to cost. I'm going to spend X number of hours. I'm going to spend $1,000 per users, and I'm going to need it for 3 months. All right, 3 months, $3,000. That's all it's going to cost. I can predict that amount and be done with it. So I don't need to deploy it and buy workstation. The other aspect that's really important is there's nothing faster today than the tier one public cloud. If you want to deploy those with the third party vendor that I've explained earlier, you can deploy that in a few minutes, and I'll show that in a second. Of course, the remote graphic protocol. This is a price per month. So if you're going with HP, for example, that come included with their Z workstation, if you go with TGX or Teradici, you're going to pay around $20 per month. And the zero client, it's around $350, $400 to buy. So it's going to cost you $30 to $50 per month. Mind you, if you're looking at a public cloud, most likely the remote graphic protocol from Teradici will be included already. So there's no additional cost to pay there. Um, I strongly advise all my customers to do a proof of concept, a POC. And again, I want to restate that too many times people think that the sender is a problem. The sender is never the problem. The most important part is to look at the applications, how those application behaves, what do they requires, how we're going to get the receiver to connect to it, and third, by importance, will be the sender. So again, look at it from that angle. The 5 steps to a success remote graphic solution. Well, the user experience, the UX, right? Define the user experience. Look at what the user is doing. Look at the application they're using. Do an audit. What is the baseline? What is the hardware and software list that they're using? What plugins they're using? Start with the baseline. Do benchmark and profiling before, during, after. This is really important. It's important to see what the user is doing. There's plenty of tools there. This is an expertise that we've developed over the last 10 years. Really important to do those benchmark and profiling. Design a solution that matches those expectations. So do a design and then do a proof of concept. Just do a sample of those users and give those users a kind of a quick sample to run and try, and then you can go and deploy. Just before we go in our quick demo, just to remind you that you can watch the daregraphic.com, our website. There's plenty of customer story and example, lots of technology discussion, bit more detail, virtualization. We have plenty of video on YouTube, so go watch this if you want to know more. And how to connect, you have my email address and LinkedIn profile, as well as Twitter. All right, so quickly for the demo. We're going to look at two options. We're going to look at the remote workstation and the public cloud. So we're going to look at those two concepts here. So first, let's look at the remote workstation. So what I brought here, so what you see in the background, their graphic background, this is the computer I'm using here today for now for the presentation. And what I brought it here is a Teradici PC/IP client that have another workstation that's sitting in my lab. So that's locally connected, and I'm basically connected to it. So I've installed, this is a regular Windows 10 machine. It has plenty of software and CPU and RAM and stuff like that. And I've installed Adobe Premiere Pro, and I can basically run that the timeline. I hope that you will have a very good visual experience from your end. What I'm seeing here is absolutely perfect. I'm seeing perfect refresh rate, and I can scroll back and forth. I can go forward, backward. It is functioning just as if it would be working remotely and local. All right, so that's very basic. So basically, Adobe Premiere Pro running in that Windows 10 machine that's in my lab. So that's running local to me. Now let's look at the quick, another example. So I'm bringing a web browser. So I'm going to use a technology by the company called Eclipse Tech, and this is going to run in the cloud. So I have two machines here ready. I have one running and one ready to run. I just want to show you the one that's not running. What can I do with that? So there is a Teradici functionality available, but then I can pick and choose the different instances for that machine. So imagine that you have your Windows virtual machine with your application already pre-installed, all of your preferences and your desktop and all that great stuff. And then you can run it. And then you can see the price range here between a 4-core, 8-core, 16-core, and all of them have a 16 gig graphic card, so very, very powerful. And they all run at 25 gigabit per second network. So I have lots of performance, but I can pick and choose between different type of VM at different costs. So the one that's here, it's already running, it's been running, I've been preparing for that demo. So if I go here, so now what I have is a browser that's connecting to that Eclipse Step Windows 10. This is a Windows 10 machine, and I'm going to launch Resolve. And basically what's going to happen is I'm going to launch a full-blown Resolve from Blackmagic Design, and I'm going to run this in a browser. Imagine that I can run these instances also via Teradici, just as I did earlier. I can run this with a Teradici client, and I just want to show you today how would that look if I would do that in a browser. So I'm going to launch this timeline, and it will launch the application. It's going to run in the browser and have full capacity, full functionality with this tool. So basically what's happening here is I have full control of that Windows machine running Resolve. I can do color grading, editing. I can do all sorts of stuff. So that's it for now. I hope you enjoyed this presentation. And again, feel free to reach us via LinkedIn on our website, theregraphic.com, and be happy to help you with your remote graphic deployment. Thank you very much.